Good morning, good afternoon, good evening, everyone, depending on where you're located. Welcome to the 10th edition of our ZTNA Table Talks. I'm Ixta Gerard, and I'm happy to have you all join us today in our monthly webinar series, where we delve into the world of Zero Trust Network Access. Today's session is titled Future-Proofing Your Enterprise, the Strategic Edge of Direct Routed Zero Trust Network Access. We will explore this topic in depth, providing valuable insights from our ZTNA experts presenting today, Jim Anthony, SVP of Field Engineering, and Justin Yentile, Director of Sales Engineering. Before we kick off, a couple of things to note. This webinar is being recorded and you will receive the recording within 24 hours. If you have any questions, please submit them in the Q&A panel and we will try to answer them during this live session. If for some reason we don't get to answer your questions, someone will follow up via email. There is an option to request captions on your menu bar. You may select translated captions using the captions request option if you need them. So let's get started. I'll pass it over to you, Jim.
Thank you, Ixta. Thank you, everyone, for taking a few minutes out of your day to jump on with Justin and I to talk about future-proofing your enterprise. Justin, are you ready to rock and roll?
Yeah, Jim, let's do it.
All right. So Ixta already introduced both of us, so I'm going to act as the MC today, and Justin is our technical guru. I've got the title up there, Technical Demo Master, but we're actually not going to give a live demo today. It's going to be more of a discussion with lots of different topics to cover. So let's dive right into it. So before we talk about future-proofing, let's talk a little bit about history. So let's look backwards. I went out and did a little research on Appgate itself as a domain name, and I leveraged the Wayback Machine. Justin, how often do you go check out the Wayback Machine?
A couple times a year, anyway.
All right. Well, I went and found appgate.com, and yes, this is the appgate.com that we work for today, except in a different iteration. We've been through some things over the last few years, but notice the copyright date down here in the bottom, 2000, and notice the date up here from the Wayback Machine screenshot. This was actually from May 11th of 2000, where Appgate was talking about securing application connectivity. 2000. If I'm not mistaken, the current year is 2024. Is that right?
It sure is.
Okay, I don't think in 2000, just thinking back to May of 2000, I don't think the term zero trust network access existed or zero trust in general. Was that a thing?
No, not at all. We were still talking VPNs and firewalls and basic
Yeah,
stuff.
I think you're right. So check this out. Just digging a little bit deeper, I clicked on a couple of links within the Wayback Machine and I found the company background. And again, this page came out from September 30th of 2000, just after 9/11, just to give you some context of when. Everybody knows that marker in history. Um, since July of 1998. So Appgate, the company, Appgate, the product, um, came into existence in July of 98. So that's a little bit of history. Let's fast forward just a little bit to something a little bit more relevant. Um, in February of 98, I'm sorry, February of '08, a full 10 years later, Vidder came into the market. Um, that's when the Internet Wayback Machine actually confirmed that that's when Vidder.com appeared on the market. But if you go look it up yourself, you'll see that there wasn't much of a website set up yet. It was just a coming soon page. Coincidentally, Zscaler also started in 2008, back in October of 2008. But let's focus on Vidder for just a second. Later in that year, in 2008, Vidder actually updated their website and they came up with this multi-stream video service for websites. So this is how Vidder started life. And Justin, do you remember anything about Vidder? I mean, you and I have both been with Appgate for about a decade now. You a little bit longer and me a little bit less. But help the audience understand who Vidder was and kind of what happened to them.
Yeah, so Vidder, while as you can see here, was originally a multi-stream video service. They eventually pivoted and got into this the market that would eventually become zero trust network access. Vitter became quite large for a bit of time, but then I think it was around 2000. Not sure if you have it on here, but around 2000, maybe 17, 16, 17 or so, Verizon acquired Vitter and effectively drove a stake through them.
Yeah, yeah, they sort of
They just kind
mothballed.
of disappeared overnight.
Yeah, I think Vitter still has a presence on the Verizon website, but I think they're more oriented now toward services within the Verizon network. So if you're a Verizon customer, you might take advantage of some of these capabilities that Vitter once had on the market. Um, but the point that I wanted to make with this little history lesson is that Vitter was founded by these guys, Mark Hoover and Junaid Islam, the CEO and CTO, respectively, for the company. They have something to say about where we ended up today. So let's get back to them. Fast forward a couple of years, 2010, John Kindervag from Forrester actually wrote a white paper called No More Chewy Centers. This started an avalanche of things, including some activity out of Google around something called Beyond Corp. They actually wrote a document around the same time. I didn't put it all in here for sake of brevity, but by October of 2011, Vitter was actually hinting at some new concepts that ultimately helped define the software-defined perimeter. By April of 2014. This is now a full 2.5 years later. The Cloud Security Alliance published the CSA SDP spec version 1.0. And guess who was on that team? Both Hoover and Islam were on the CSA team that helped develop that spec. So the guys that founded Vitter actually resurfaced in helping to write this software-defined perimeter specification. The interesting thing about that spec is that it actually calls for two access methods. And we're going to talk in more detail about it, but no reason to dig into it right here. But that specification, even way back then, talked about this concept of a service initiated connection and a client initiated connection. Two distinctive capabilities within the software defined perimeter world. And we'll talk more about it in just a second. Justin's biting his tongue basically because I'm not letting him talk at this moment. But um, fast forward again a little bit in also in April of 2014, a little company out of Coral Gables, Florida, named
Organs.
Medina Capital, purchased the company called Appgate that we just looked at their website, and renamed it to CryptZone. Acquired a couple of other companies, including the company that Justin worked for. And moved its headquarters to Boston, Massachusetts. That didn't all happen at the same time, but it all happened over a window of time that's, could be described as a 12 to 18-month window. In August of 2015, a guy named Jason Garbus actually joined CryptZone as its chief product officer. That happens to be the same month that I joined the company as well. So I actually joined CryptZone back then, leading the sales engineering team. Well, Jason actually became a contributor to the CSA SDP spec version 2.0 right after his employment with Appgate. And, he signed up with the CSA, jumped onto this working group, and actually eventually became its chairperson. And so for the next few years, Jason sort of had a dual role concept going as the chief product officer for CryptZone, as well as the chairperson for the CSA SDP spec version 2.0. Why does it matter? Well, let's dig into it a little bit. So what the net is that basically by the year 2015, CryptZone and Vitter were the first two companies in the market with a software-defined perimeter solution. Um, all three of these guys, Hoover, Islam, that I mentioned, were at Vitter, as well as Garbus at CryptZone. They were all influential in where this 2.0 specification was headed. Um, both, again, in the 2.0 spec, both the client initiated and service initiated concepts were included, but the two products on the market from Vitter and CryptZone were both client initiated solutions. These would eventually become known as a direct routed concept, and that's what really we're here to talk about today. Zscaler ultimately came along after the fact. Like I said, they hit the internet in about 2008 and were focused on their ZIA product, also known as Zscaler Internet Access, also fitting into the category of a secure web gateway, a category of product that's existed for many years prior to 2008, but was typically handled by on-prem boxes like Blue Coat Networks and things like that. But by 2016, they had actually created a private access solution that leveraged the network and the series of points of presence on the internet that they had deployed for their ZIA service. They adopted this service-initiated concept, eventually becoming known as a cloud-routed concept within the Zero Trust world. And not to be too dramatic, but thus the Zero Trust wars actually began. Justin, did I make sense there? Did I trip over anything?
No, I think you hit the nail on the head with the background here that we need to know about, Jim.
All right, so let's dig into it. So now we find ourselves fast forwarded a few years into the future, and we've got these two different models, this direct routed model and this cloud routed model. So Justin, would you take a minute and sort of help us understand at a really high level what's different between these two models?
Yeah. And I'm actually going to take it from the bottom up here, Jim. So with the cloud routed model, which is essentially almost all of the other vendors in the ZTNA space that exist today, um, basically you're actually forced to route traffic from an endpoint device through a policy enforcement point that actually lives in the ZTNA vendor's cloud environment, where that traffic is then brokered down via connectors that would live in your on-prem data centers or your IaaS environments. And with the cloud routed model, while on the surface it might sound like a good idea, when you really dig into it, there are a number of significant challenges with that model. First and foremost, because of the fact that you're artificially routing traffic over someone else's network that traffic would not otherwise need to traverse in the pathway to reach your private resources, you're artificially adding hops to that traffic, which means you're going to see an increase in latency. Oftentimes, bandwidth will be constrained or becomes very costly at scale. And also, because of the nature of the fact that most of these solutions are proxy based, there usually are limitations around the types of applications and protocols that they can actually support. Not to
Interesting.
mention not to mention the fact that with the cloud routed model, you're also 100% beholden for all of your users' access to any of their private resources from a security and availability perspective. So an outage or a breach of that vendor's cloud environment, then all of your users will be immediately impacted. And so the alternative is the direct routed ZTNA model, which Chapgate employs. And that with that direct routed ZTNA model, the data plane is extended directly from an endpoint device through policy enforcement points that live in the customer's networks and never through any AppGate owned infrastructure or the vendor's infrastructure, for speaking generically. And so in doing so, oftentimes direct routed ZTNA solutions are able to overcome a lot of those challenges that I just described with the cloud routed model, and also solve more business problems rather than just being for remote access, which is what most of the cloud routed solutions are intended towards.
Okay, so let's dig a tiny bit deeper here. So when
Mm-hmm.
you were describing the cloud routed model, you mentioned a couple of key words that I honed in
Mm-hmm.
on, multi-tenant and beholden. Is it fair to say that if you sign up for a cloud routed solution, there's some level of trust that you need to supply to the cloud routed vendor? Are there things that you have to trust that they're doing in order to fulfill the use case that you're bringing to the table as a customer?
Yeah, definitely. In almost all cases, the traffic is actually decrypted at the cloud routed vendors in the cloud routed vendors vendor cloud environment, where the vendor will tell you that they're going to do some traffic inspection on it and so forth. But at AppGate, we don't think that that's a good idea to first of all to have your traffic decrypted in a public or excuse me, a multi-tenant environment such as one of these. And we don't think that that's the right place or the right type of traffic to do that type of introspection on. So essentially, it's really kind of an unnecessary step that exposes the customer to a lot greater risk of an incident.
Okay. And then coming back up to the direct routed model, there's always some subtle differences between these diagrams.
Hmm.
The cloud routed model has a cloud around
Hmm.
the PDP, and there's this broker or proxy PEP in it. Whereas on the
Hmm.
direct routed, that cloud is sort of missing. The
Hmm.
controller is still hanging out in roughly the same place, but there's not a cloud around it. And then there's this PEP function looks like it's shifted to the edge of a customer network.
Yeah.
Am I picking up on that right? Where does this PDP actually run in a direct routed model?
It's a great question, and the answer is where do you want it to run? You can deploy it in any location that makes sense for you. You can deploy it in a traditional data center or in your AWS or Azure or GCP environment. And in fact, if you want to, there are also options. Well, AppGate at least has options where we can actually host that controller if desired by the customer. But to be clear, even for our customers that might choose to have the controller be hosted by AppGate, it is always going to be single tenant. So we stand up individual controllers for each customer in a siloed environment. And in addition to that, the data plane is always directly extended from endpoint devices through policy enforcement points that would live in the customer's network. So it's the data plane is never going to traverse AppGate-owned infrastructure.
Okay, that's pretty awesome. No
Yeah,
implicit trust required there. Um,
right.
Focusing in on this side of the equation, the user side, or I guess you could call this the requester of info.
Mhm.
What enables this user or this device to actually communicate into this PDP and PEP concept? What's happening over here?
Yeah, so there's always a client involved, right? So the client is what initiates the connections. With AppGate, there's a full thick client that can be deployed on any endpoint that runs on a major operating system. So we support Windows, Mac OS, Linux, Chrome OS, Android, and iOS. But there also are other client solutions that can actually help solve problems from other types of systems and endpoints, things like IoT devices, legacy operating systems, even containerized applications that run in Kubernetes clusters.
And then does the same model exist down here? Is there some sort of client running on these cloud routed models too?
There is, yeah. So definitely, there's always going to be a client involved with all of these types of solutions. That client might look a little bit differently for different vendors and so forth, but there's always going to be a client involved. So
Okay. So the infrastructure required, the things to deploy, the things to configure on the
mhm,
direct routed model actually seem a little easier. There's fewer things. I've got a client, I've got a PDP, I've got a
mhm,
PEP, but
mhm,
what I don't have is I don't have this proxy. I don't have a
right.
limitation of protocols related to the use of the proxy.
Mhm,
And then I guess there's also no inherent trust built into the vendor here on the
right.
direct routed model.
Yeah,
Would
absolutely.
that summarize everything right?
100%.
Okay, well let's dig into some of these differences in a little bit deeper and more focused manner as we shift through. So let's first of all let's talk about shared versus not shared. I think that was one of the key words that you mentioned in describing those two different models. Um, so as I understand it, cloud routed and even direct routed, they've got some of these requirements that no matter who the user is, no matter what kind of requester it is, Zero Trust is really focused in on user authentication. There's applications that have DNS names that need to be resolved both publicly and privately, and then there's some concept of packet inspection. Um,
Mhm.
you know, on the direct routed side, what's the difference, right? So in these three categories, tell me how this relates to the direct routed side.
Yeah. So, well, with regards to authentication, if you're using something like traditional Active Directory, in a lot of cases, the cloud routed vendors are going to require you to actually synchronize your AD up to their solution for that authentication. Whereas with a direct routed vendor, because of the fact that the controllers can be deployed local to where the Active Directory or LDAP infrastructure actually exists, there can be a direct interaction and direct communication between the controller or the PDP and the identity source of truth. So we can kind of overcome that problem. With regards to name resolution, oftentimes cloud routed vendors do require a zone transfer. So, the cloud routed vendors are going to have an entire copy of all of your internal DNS records, which obviously could lead to some bad things. Um, with direct routed models, it's not the case. Essentially the solution can be configured to communicate directly with internal DNS in real time and to resolve names as needed.
So let
And
me
then,
break.
yeah,
Oh,
yeah,
go ahead. I
sure.
thought you were done. Go ahead, Justin.
Yeah, no, with packet inspection, I kind of already touched on this anyway earlier, but But essentially, with packet inspection, it does require oftentimes that, or actually not oftentimes, but it always is going to require that the vendor be able to decrypt your data in order to do that, perform that packet inspection. And at Appgate, we frankly just don't believe that that's the right place and the right time to do that type of an inspection. You obviously want to inspect any traffic that's leaving your networks, but in transit between your users and the data center typically is not the right place to do that kind of an inspection.
So let me play Captain Obvious here for just a second. So if I were running a set of systems in a set of data centers for a company, and I was responsible for securing that environment,
Mhm.
I'm guessing that I would not want my users' identities to get out into the wild. I'm guessing I would not want my encryption keys to get out into the wild. And I'm guessing I would not want my internal DNS names and IP addresses to get out into the wild. And yet you're telling me that in a lot of these cloud routed solutions, these are exactly the things that I have to share with them. Is that what
Yep,
you just said?
it's pretty much what I said, Jim.
All right. Captain Obvious out. Um, let's shift gears for a second then. Let's talk about users now. So from a user perspective, I think performance is always a very important concept. But simplicity of use is another important concept. When do I use this solution and when do I not use this solution? Not everybody works in IT, right? You have clerks, you have admin assistants, you have people that have very specific functions and jobs, and they just want to do those jobs without being bothered about knowing how IT stuff works. How does that come into play with a direct routed versus cloud routed experience?
Um, so
Sorry, that was a really open-ended question. Maybe I can dive a little deeper on a few concepts. Um, so as an end user is using either a direct routed or cloud routed experience or a cloud routed solution, what might be one of the very first things they notice as they come to work and start working, whether they're working from home or working on-prem or working in a coffee shop somewhere? What might be one of the things they start to notice to help them understand that this cloud routed thing is causing one set of behaviors versus a direct routed thing causing another set of behaviors?
Yeah, I mean, well, so first of all, the performance might be impacted by that, right? I mean, so access to resources might be a little bit slower than you might expect. So with a direct routed solution, obviously that's going to be significantly less impactful.
Interesting. Um, what about if I'm on-prem, do I still need to use this access solution? Is it required?
Yeah.
Is it a good practice? Is it a best practice? How does that come into play?
Yeah, I think with any good zero trust network act solution that was designed to be able to handle it, it is a very good idea to run the solution regardless of whether the user is locally connected within a corporate office or if they are remote at home or at a coffee shop or an airport or something. In doing so, you're applying the consistent policies for access to your data regardless of where the users and the devices are sitting. The fact of the matter is, though, that with a lot of the cloud routed solutions, since they aren't built for this. This means that things like hairpinning comes into play. If you think about a scenario where an end user is sitting in a corporate office where there happens to also be some server based infrastructure even a network closet or a data center within that same building, that user's traffic, oftentimes with the cloud routed solutions, needs to be routed out to the public internet through the vendor's cloud environment and then hairpinned back into the network. Obviously, that's a suboptimal experience. Whereas the obvious alternative there is with the direct routed model, traffic is routed directly within the data center, or excuse me, within the office, within the building to the data center.
Okay, so because of the fact that that policy decision point and that proxy are running in the vendor's cloud, any
Mhm.
user access, regardless of where that user is sitting and regardless of where the data center is in proximity to that user, it must
Right.
involve routing through that vendor's cloud platform, right?
Yeah.
So,
In most cases, yeah, that is definitely the
okay,
case. Yeah.
so the
Yeah.
internet is almost always involved in those scenarios.
Mhm.
But in the direct routed, you're saying that the user and the data center could exist on the local area network, and
Right.
take advantage of routing directly to the solution. Is that what you're getting at?
Yep. 100%.
And then, so
Yeah.
how does that apply to things like, SD-WANs and MPLS circuits and direct connects to the AWS data centers and other cloud-based platforms? Is there a difference in how that's handled from a direct routed side versus a cloud routed?
Yeah, I mean, ultimately, direct routed solutions are overlay solutions, right? They're intended to live and ride over any layer two network. So it really doesn't matter what the underlying transport is. The solution is going to work just the same as long as it's IP based. That's really all it comes down to. So, in a lot of cases, actually, direct routed solutions, because of the fact that they can help to securely connect users and devices from any location to any other location, there is a potential for reduction in the need for these types of technologies like MPLS or SD-WAN. But it's certainly not a requirement. Then, solutions like AppGate SDP can ride over any of those.
Okay. And then thinking back to the two diagrams, I think both of the diagrams, both cloud routed and direct routed, had an entry point that needs to be deployed in the customer's data center or the customer's
Sure.
cloud environment. Tell us about that entry point. Is that a single entry point? Is it scalable? And how does that impact user performance?
Yeah, I mean, it obviously is. It has to be scalable, right? I mean, because no two organizations are going to be the same exact size, right? But with AppGate SDP, the AppGate gateways are very scalable. An individual gateway's capacity can be determined by how much memory and CPU in general. That's the discuss scaling would be determined by memory and CPU allocated to that instance. But also, our solution can be scaled horizontally. So by simply adding additional gateways in parallel to ones that you've already deployed, you can increase the capacity of the solution. And in
Okay.
fact, because of the nature of the way that the AppGate gateways are designed, they are orders of magnitude greater orders of magnitude greater performance than the cloud routed solutions do as well.
Is there some sort of inherent limitation built into the cloud routed side of the equation?
Yeah, I mean, I think there is obviously the vendors having to route through the vendors' POPs is going to add some sort of a limitation, right? But I mean, there obviously are a ton of different factors there that go into this, but bandwidth isn't free for those cloud routed vendors, so oftentimes throughput is very costly at scale. Um,
Interesting. So you got to worry about that too, I guess. All right. It's kind of a bleak picture you're painting, Justin, I got to tell you.
yeah.
All right, so let's talk real quick about availability and persistence. So what's the difference here? I'm as a customer of a cloud routed solution, I'm relying on that vendor to make sure that that cloud's available. Well, how's
Mhm.
that any different than relying on Amazon to make sure that their stuff is available, or Microsoft to make sure that Office 365 is available? And how is that different than what's available in a direct routed scenario?
Yeah. So with a cloud routed ZTNA solution, any type of an incident in the cloud vendor's environment is going to impact 100% of your users immediately. Whereas the contrasting example that you gave there with if AWS were to have some sort of an outage, usually that's going to be a regional thing, and so some of the access to some of the resources that you've deployed in that AWS environment might be impacted if there were an outage, but not all of your users access to everything that they need to get their jobs done in a lot of cases. Um, and we can solve for that by hosting things in multiple availability zones and so forth, right? Whereas with a direct routed solution, you're simply just not impacted by that type of a problem. As long as you've properly deployed your AppGate SDP solution, you're going to deploy with multiple individual points of redundancy, in the form of multiple gateways in each of the locations that you've deployed resources in. And in addition to that, AppGate also supports some features that can allow you to build redundancy upon redundancy, where even if you lost all of the gateways in a particular environment, you could potentially route traffic over another network link to reach the resources in that environment.
Ah, interesting. So the net of it is that in a cloud route scenario, as a customer, I've got to rely on that vendor to make available and create alternative disaster recovery routes or things like
Yep,
that. But in the
definitely.
direct routed model, I can become responsible for that. I can take responsibility for it and make decisions about how I want to scale my solution, how I want to make it redundant, and as you mentioned there at the very end, how I might even want to route traffic to an alternative data center if I've got a localized outage in one of my data
Right.
centers. That's all good stuff. And again, I think leaning on that you know cloud routed is really that zero trust plus one model versus
Mhm.
direct routed being truly zero trust. Does that resonate?
Yeah, yeah, definitely. Yep.
All right. So we talked earlier in the diagram about the cloud routed model leveraging proxies generally,
Mhm.
and versus the direct routed model generally leveraging firewalls. This isn't always the case with every single vendor, but most of the big players kind of fit into these two categories. Can you give us a little idea about what this looks like, comparing one access method versus another?
Yeah, quite frankly, just proxying oftentimes results in a limitation of the types of ports and protocols that these types of solutions can actually support. As you can see here, there are a few listed that are, well known and work well with proxies, but other types of applications and protocols quite simply just don't. Some of the ZTNA vendors have managed to overcome some of this even with their proxy architecture, but oftentimes that's at the expense of performance for other protocols. Um, and direct routed solutions use firewall rules. So it's the AppGate gateways, for example, are natively filtering traffic and forwarding it onto the network. So there's no proxy-based architecture involved, which means that all major IP protocols can be supported. So any application that talks over TCP, UDP, ICMP, ICMPv6, ESP, AH, and GRE can be supported.
Wow. Okay. So you say firewall rules. Just to dig into the
Mhm.
nitty gritty,
Yeah.
are these firewall rules integrated to my existing edge firewall, or is something else magical happening here?
Yeah, no. So the AppGate gateways are actually we actually use a term that we call micro firewalls per user. So there's actually a tiny firewall table for every single user or device connection, which is done for performance purposes. It allows for our gateways to perform at very high scale since they don't have to process tens of thousands of firewall policies when a packet is received from an end user device. Um, so it kind of offloads the burden from your traditional network firewalls. But with that said, it certainly doesn't need to. It isn't intended to replace your next gen firewalls that sit kind of at the edges of your networks, which obviously serve some additional purposes in the form of deep packet inspection, content filtering, perhaps, and other stuff as well.
Oh, okay. So because they sit at the edge of the network and the traffic is unencrypted post firewall, you can
Yeah,
leverage your in data center packet
sure.
inspection tools already, right?
Yeah, absolutely.
Okay, well, I know a thing or two about proxies and firewalls, and I generally know that proxies are denote a unidirectional flow of information.
Mhm.
And firewalls typically support bidirectional flows of traffic and access control. What's the difference there? Why would I want a bidirectional technology like a firewall controlling traffic into and out of my data center? What's the difference?
Yeah, so there may be cases where, well, sorry, in most cases, when you're defining access policies in a ZTNA solution, it's really the source of that traffic would be from an end user or an endpoint device. But there are cases where you may need to allow for a server-initiated communication down to an endpoint device. So, for example, if you want to run a vulnerability scan on your endpoint devices for users that aren't present in a physical office, or if you need to allow for an administrator to remotely RDP into an end user's workstation to help troubleshoot an issue. So the kind of server initiated becomes kind of important for some of the specific IT related functions there that we might have.
Okay, that's very interesting. Um,
Yeah.
and so I also think about firewalls and the concept of HA firewalls. is there some level of HA concept built into the direct routed model that I could take advantage of? How does that work?
Yeah. When an endpoint with an AppGate client connects and is told that there are entitlements in a particular location, network location, say your data center or your AWS environment or whatever, the AppGate client will actually connect and establish a persistent connection to one of the AppGate gateways that live in that environment. But if as long as you've deployed more than one, which in any sane person is going to deploy at least a pair of them for redundancy, right? So if the gateway that endpoint device is currently connected to should ever go away for any reason, the endpoint device, the AppGate client, would automatically reconnect through the other available gateway, and the session can be resumed in a very fast manner that's oftentimes seamless to the end user, and traffic just resumes as normal.
Okay. I know that in an HA scenario, there's a state table involved in transferring
Mhm.
between the HA firewalls as well. Does that come into play with AppGate?
Yeah, no, not really. It's not really necessary because of the way that our gateways were designed. So essentially, there really isn't. There's not really much to hand off except for the access that the device should have, and the endpoint device, when it connects to a gateway, actually presents an encrypted set of tokens to the gateway that came directly from the controller, and so that session can actually be resumed very quickly with the same access being configured immediately on the new gateway that was available on the old gateway.
Okay. So let's keep digging a little bit on the performance and the user experience. I tend to think of performance as being based on, the user experience in general, but outliers especially, things that go bump in the night from an individual or small set of your users in
Mhm.
particular. And I think of, the ability to execute things rapidly, connect rapidly, minimizing hops. What are some of the other things that come into play with performance and user experience?
Um, well, I mean, I think you said most of it there, but obviously, uh, user experience is very important. So, I mean, uh, I guess I'm not really sure what else you want me to say there.
Yeah. Um, so when it again thinking about cloud routed versus direct routed and thinking about
Mhm.
these routing traffic out to POPs out in the internet for the cloud routed scenario, how does that come into play if a vast majority of my users actually sit in the corporate office and that happens to be co-located with a data center? Is there a cost implication there with routing that traffic out to the POPs?
Of course, yeah. Your bandwidth is you're gonna see almost double or in most cases you'll see double the consumption of that bandwidth because the traffic does need to traverse out to the public internet and then be hairpinned back in.
So I may actually have to go and increase my internet pipes as a
Yeah,
result of adopting some sort of cloud
sure.
routed solution, right? In that scenario.
Yep. Yeah.
Okay. All right. Well, it feels like we whipped that horse enough. Let's try to move on. I think in the update literature, we talk a lot about universal ZTNA. Give us a quick rundown. What does this term universal in front of the ZTNA concept? What does that mean for us?
Really, it's that any device trying to talk to any resource. So it's the any portion of that, or everyone, as you can see on the slide here. But basically, it's intended to universal ZTNA solutions are really intended to help you connect not just an end user, but it could be any other type of thing, including things like IoT devices or legacy operating systems and things like that, to any resource that lives in any location. So that can be in your traditional data centers or in an IaaS environment or even your SaaS applications. So in other words, why should your ZTNA solution box you in and really only be usable by your end users' devices, for access to resources in, maybe even only a subset of data center type environments?
Interesting. So I see in the every list up at the top of the screen, it's talking about every network type, every location.
Mhm.
Are there
Yeah.
limitations in network types?
With AppGate SDP, there really aren't. I mean, it's really you can deploy the solution in any place that you have resources that you need to protect and control access, and your users can actually sit in any network as long as they're have a connection either locally within on the LAN or via the internet to your AppGate infrastructure. They'll be able to reach resources that they need to do their job.
Okay, so just to summarize a little bit, it seems to me like the direct routed model opens up some concepts and capabilities that give flexibility in the types of networks, the underlying connections, the types of protocols, whether I've adopted IPv4 or maybe I'm an early adopter. Is it still early to call adoption today of IPv6 early? I don't think so,
I
but
don't think so either, but
it seems like direct routed opens up some of these ideas a little bit. What are some other unique and interesting things that you can do with a direct routed model that you definitely couldn't do if you've got to route all the traffic out to a POP on the internet?
yeah, I mean, I would say the biggest thing is obviously if you've got to have an environment that is completely disconnected from the public internet. So if you have a requirement where your users are, in a disconnected, tactical edge, for example, environment, there's obviously with cloud routed solutions that's not going to be possible because they need to be able to talk to policy enforcement point and be able to route traffic through those policy enforcement points that live in the vendor's cloud environment. With direct routed solutions, you can actually support some of the examples that you see here in front of us here. So if AppGate does a lot of work with the U.S. Department of Defense, and we are actually the most widely deployed ZTNA solution across the U.S. DoD. And so part of that is because we can support these very specific situations where they've got ships at sea that might not always have, for example, good satellite connections back to land-based infrastructure. And so there can be components of the solution that are deployed to completely allow for the users and resources that need to access things on the ship to still securely do so, even when that connection doesn't exist.
Okay. What about in a completely air-gapped environment, like say a
Yeah,
government skiff? Do we have
sure.
a play there?
Yeah, definitely. Same reason. I mean, same points still apply there. But I mean, if there's a requirement to have the network completely disconnected, you could still deploy AppGate SDP to support that.
Okay. As long as all of the required components are within the skiff, like the authentication method, the gateway, the PDP, the PEP, I get it that we could run inside of that environment without ever talking to the outside world. Fair enough.
Right. Yes, definitely.
All right. Well, let's try to bring this thing home a little bit. Let's talk about some dirty little secrets. So, you know, from an internet and network perspective, I have some networking one-on-one. All things on the
Hmm.
network that you need access to, you've got to make a request to an open port.
Hmm.
Um, so how do cloud routed solutions make these requests, especially these initial connections, versus
Hmm.
how does AppGate do it? What's going on there?
Well, so there's always got to be an open listening port in order for to allow for any type of a connection initiated to something else, right? So there's got to be an open listening port that's ready to respond and accept that connection. With the cloud routed solutions, obviously, this means that the perimeter of an organization's network, there doesn't necessarily have to be any inbound open ports that are actively listening, but instead the connectors with those types of solutions establish outbound connections to the vendor's cloud environment. However, that really is just shifting the policy enforcement point away from the perimeter of your network to the perimeter of the cloud vendor's network. And what that means is that the cloud vendor now becomes a target for attackers
Okay.
as opposed to your local network.
So that pop out on the internet, it's listening. It hasn't. We've just
Yes,
shifted
it
the
has
open
to.
listening port out to the pop.
That's correct. Yeah.
Okay.
Yep.
So how's AppGate different?
Yeah, so AppGate leverages a technique called single packet authorization, which essentially cloaks all of the AppGate server components. So all of the AppGate appliances, while they have to be listening for inbound requests as part of this service-oriented architecture, single packet authorization effectively makes it such that in order to communicate with one of those AppGate appliances, you must have an AppGate client that's properly configured with a profile that includes a valid single packet authorization key in order to initiate that connection. And so, in fact, if you were to run a port scan against the perimeter of a network that's protected with AppGate SDP, you won't find any open listening ports. They appear as though they are invisible. Even if you somehow knew that an AppGate appliance existed on one of those networks, you can't connect to it and get a response from it without an AppGate client that's properly configured in this manner.
Okay, so this single packet authorization key,
Mhm.
it's created by AppGate or created by customers? How does that
By
work?
the customer. So the customer completely owns and manages. They can issue or revoke those keys at any time.
And they can have one such key or many such keys?
Yes, yeah. So in most cases, customers will define maybe one for corporate users, and then additional single packet authorization keys for example, for each vendor maybe that they have to do business with, and where if you ever want to sever ties with that vendor, you can just disable their single packet authorization key, and none of those users who formerly had access would be able to even discover the perimeter of your network again.
Okay,
Yeah,
sounds pretty awesome.
yeah.
Let's dig into another one. So, oftentimes decisions to purchase different products are made based on operational impact, managing deployments and components, uh, trust and risk and compliance come into play. What are some differentiators between cloud routed and direct routed with regard to these concepts?
So with cloud routed versus direct routed, you're really shifting a lot of the trust out to that cloud vendor's environment, and so there obviously are responsibilities that the vendor takes on, with regards to making sure that the solution is always secure, as opposed to you having full and total control over the various components that make the solution work with a direct routed solution.
Okay. Are there different management responsibilities? I mean, if I'm a customer of a cloud routed solution, am I managing the environment any differently than a direct routed or vice versa?
Um, well, with regards to policy, you're really not. I mean, the solutions are going to be the same in both cases. You're going to be you're still responsible. The customer is still responsible for management of all the policies and decisions on exactly which users and what devices can access which things at what points in time. So the management from that perspective is always going to be the same. Um, you know, so yeah,
Okay. Well, all right, you sold me on this direct routed approach. I'm going to buy direct routed. But I really run a small shop. I
yeah,
really don't want to be responsible for the daily care and feeding of some of the components,
yeah,
like doing upgrades or making sure that redundancy is still redundant and things like that.
yeah.
Are there options with AppGate's direct routed model that would allow me to shift some responsibility to back to AppGate or maybe to a third party? Do some of those things
Yeah,
exist?
definitely. Yeah, absolutely. So I teased this earlier, but the AppGate controllers, which can be deployed in any of your networks that you own and manage, if you don't want to manage the infrastructure, AppGate can host those controllers. And when customers do opt for the AppGate hosted model, along with that, the AppGate would manage the maintenance and the care and feeding of the various gateways and other appliances that are deployed. So really, in that sense, for AppGate hosted customers, the customer that choose to have the controllers hosted, the the customer's responsibility from a management perspective becomes nearly identical to a cloud routed solution.
Okay. And this option from AppGate that has a name. It's called.
The ZTP hosted, or Zero Trust Platform hosted.
Okay. And so if I choose to go down that path, and I want AppGate to be responsible for some of those components, um,
Mhm.
are those components still dedicated to me, or are they shared with
Yeah,
other customers? How does that work?
no. Yeah, so it's always going to be single tenant architecture. So for any customer that it gets onboarded, there's unique controllers that are stood up for that controller exclusively, and the only people that would have access to the controller are the customers, administrators, and a handful of select support engineers under the appropriate circumstances to reach out and perform maintenance and so forth on those controllers.
Sounds promising. Are there other features and capabilities of this ZTP platform that I might be able to take advantage of?
Yeah, definitely. So our Zero Trust platform, while one of the functions is to provide a means of hosting the controllers for customers, there also is some additional risk modeling that's built into the Zero Trust platform that allows for our ZTP platform to act as a sort of a clearinghouse of information sharing between or from other third-party vendors. So, for example, we have built some integration points with leading EDR solutions like SentinelOne and CrowdStrike and Trellis, and with configuration tools like Intune and so forth, wherein AppGate can actually reach out to these types of solutions, grab information about, for example, the risk level of an endpoint from a CrowdStrike perspective, or validating that the endpoint is registered within Intune. And AppGate can take and consume that information, and you can build your policies around these types of elements to as used as a basis for determining whether access should be allowed or denied or further scrutinized before you allow access.
Okay, awesome. And you're telling me that that integration's built in and ready to go. I wouldn't have to actually write any code or anything to make that work.
Absolutely, yeah,
Okay, well, that seems
yeah,
to ease my burden a little bit too.
yeah.
All
Definitely.
right, we're quickly running out of time. Let's try to bring this thing home. Um, we've got why the direct routed architecture matters here. Let's run through this, right? So in review, we've really focused on calling direct routed the AppGate way. I think that that's pretty much because Vitter is mothballed at this point, and they were the only other major player in the direct routed architecture. Um, is that a fair statement, Justin?
Yeah, there are a couple of other smaller vendors in that would fall into the direct routed category. They use most of them, or as far as I know, they use fundamentally different technologies for that, and there are some other downsides to it. But if apples to apples, I think that AppGate is obviously AppGate SDP is the leader in the direct routed space.
Okay. So in terms of full control and direct access without hairpinning, it looks like we've got a comprehensive list summarizing a lot of the things that we talked about for the last 54 minutes. Um,
Hmm.
Anything else to add? Did we miss anything?
I'm quickly scanning this list, and I don't think that we missed anything. I mean, I think we kind of highlighted all of this stuff here. So, I mean, I don't think there's really any need to beat a dead horse, but this really provides a really good summary of the things that we did talk about here. Really
Okay.
what it comes down to is, that AppGate, all of these categories that you see here, which should take seriously, is going to provide you with a better pathway to solving problems.
Yeah. All right, it looks great. So just to a final plug here, if you like what you heard today and you might want to experience AppGate, the direct routed approach, um, uh, also known as, according to the SDP specification, the client initiated approach. Pop out to appgate.com/ZTNA free trial and sign up for a free 30-day trial. No fees, no commitments, no contracts. Uh, Justin, myself, and the rest of the technical team at AppGate will gladly answer any questions, help you if you get stuck, or help you expose some new and interesting use cases you might not have ever thought of with a direct routed approach. But that's it for today, and I want to thank everyone for jumping in. I actually do not have the Q&A panel open, and I'm wondering if either Justin or Ixta, if you've got it open, if you can see any Q&A questions, uh, could you pop in and maybe throw them out there for us? Oh, wait, I do have the Q&A
Yes.
panel open. I do have it open now. So we do have a question that came in and talked about FedRAMP approval. Um, And so, Justin, do you want to address the FedRAMP approval concept?
Um, Actually, yeah. So if you think about the way, I sorry, muted myself by accident there. So yeah, actually, Jim, can you take that one?
Well, so first of all, the idea of FedRAMP is data center oriented, right? So FedRAMP audits are for services that exist inside of data centers. Um, And because AppGate is deployed as software in your data center, in your space, then it's actually not needed for AppGate unless you want to take advantage of ZTP, which is a third-party data center where ZTP platform is deployed that will need FedRAMP approval, and it is not there yet. We have not gotten FedRAMP approval for that component of the AppGate architecture. So any deployment that needs FedRAMP as a requirement, AppGate is still in play, but the ZTP things that Justin talked about would not be possible for FedRAMP requirements. And so we are working on it, but it's a long and arduous process, to say the least. A couple of other questions around user identity and issues. So Justin, maybe give us a brief understanding of logging. Let's hit that as a generic way to answer issues related to individual users and what that may look like. You're on mute, buddy.
I'll keep getting on mute. Sorry. AppGate correlates an extremely rich stream of events detailing exactly who accessed what, when, and under what circumstances. And so essentially, we give you a very easy way to kind of identify exactly, who did what and when, and help to troubleshoot them in that way.
So is it fair to say that we could actually collect these logs from an AppGate perspective in each one of the components and feed them
Feed them
to?
into a SIM solution of choosing. Yeah,
Okay,
absolutely.
okay.
And yep. So we can support tying into any of the major SIEM solutions, Splunk, Sumo Logic, and more.
Okay, awesome. Well, that brings us exactly to the top of the hour. So, Justin, thank you for being the expert on the call today and all of the questions that I posed in real time. And Ixta, thank you for your support and helping us move along. We're done, and look forward to hooking up with everybody later.
All right. Thanks, everybody.